not everyone will have MPLS connection. Some will have MPLS only. Some will have internet only. Some will have both. You see, there may be policy for some traffic. You should take MPLS tunnel, which means it will go to R3 and then take the tunnel, go to R6 and go to the remote site, for example. For the remote site, it goes through the tunnel. What if MPLS got issue? What if the MPLS link path got some issue? So for the backup, sometimes ISP itself will allow your traffic to go through an internet connection so that via internet you can go to the remote office. Or sometime for the WAN connection, meaning for the remote office, your policy is to use MPLS. But to go to Yahoo, how you can go? You have to go straight. Yahoo is somewhere here in the internet cloud. So you need to go this way. You cannot go through the tunnel. You will not reach Yahoo if you go through the tunnel. So one may need both a WAN connection to reach to the remote data center, and the other one is to reach the rest of the world. The rest of the world is through router 9. Through this also, if they want, they can be normally IP routed to the remote site, but we are not going to consider that. I just gave you an example why we need internet connection when we have WAN. The more important reason why we need internet connection is to go to the rest of the world. With the WAN connection, WAN connection is not internet. WAN is wide area network. Using your own tunnel, you reach your remote office. So using WAN, you can go to Yahoo, Google, Facebook, rest of the world. So how are we going to allow internet access to this customer? To simulate this, I'm going to keep this internet out of the service provider circle. And I'm going to create a loopback here. This loopback, if one can ping loopback, they can ping Yahoo. You understand? Mm-hmm. If this customer 78 can ping 999, which means they can go Yahoo. But customer customer R7, R8 should not ping R1, R2.
Right.
R1, R2 should ping 9999, but should not ping R7, R8. What I'm trying to say here is, you see, both these customers should ping internet, but they should not be able to ping each other.
Right.
So what I'm going to do is I'm going to change the subnets. Here I'm going to make this a 7 so that we will have clarity. We should not have any confusion, so I'm just changing it. Earlier we had the same subnet to understand that if two customers have got same subnet, that doesn't matter because it is two separate control plane.
Yeah, right.
Now those things we have learned already, so I'm just changing the subnet here. And even here, I'm going to change this. This is not going to be 13, this is going to be 73. And here 68. I've seen in the real world, most of the time service providers provide a private network between R1 and R3, R7 and R3. Why?
Okay.
Because it's just for tunneling.
Okay.
But when they want to have internet connection, they will not give private, they will give public. I repeat, if someone wants both MPLS as well as the internet, they will be provided with a public IP address because they also need to go to internet. But when someone wants to go only to WAN, remote office, they no need a public IP address. Just think and try to understand. Is there really need for a public IP address for having tunnel? Are they going to talk to
No.
any public domain? No.
No. No.
They're just going to go to the PE. From PE, they're going to they're going to be tunneled. Using the tunnel, they go to the other end and the other end to the remote office. So we see here only the we see only the private address needed. There is no need for public. But if you want to talk to internet, you need public, or they will do netting for you. Who will do netting? ISP will do netting for us. Yes, they will do netting for you because they did not give you public IP address. Whenever traffic wants to go to this cloud, they will have NAT policy here on this link. ISP will do that. Did you get my point?
Yes, sir.
Okay. Let's go and configure first router 9. I need to do a lot of changes to the existing configurations on R7, R8, R3 and R6. After which I need to put the routing protocol, RIP and EIGRP. After that only we'll be testing this, but before that I'll put basic configuration on router 9.
Okay.
Internet interface loopback 0 IP address. And then interface F00. That's going to be a public link there. Or there should be a netting there. Anyone. Let us take public itself. I'm going to say 39. Like this.
I didn't make that 69. 96.
96, sorry. 96. And after this, we're going to run some routing protocol between R3 and R4. Let us do BGP. Usually we do BGP in the real world. So I'm going to say BGP 999. Okay, next. Let's do the configurations.
9. Three.
Okay, next. Next is on this side. Let us correct all this type, this changes that we discussed, and then we'll move on to the other portion.
Okay.
So on R7, we are going to have interface loopback zeros IP address as 192.168.7.7. And
You said 24. You said it was a 24-bit address. 24/24. Sorry.
Okay. 24. No problem. Next is interface F00. I'm going to say 73. Next. No IP router OSPF. No router OSPF. I removed OSPF from here, so show IP interface brief should have 192.168.7.7/24 73.73.7. Show IP route 24.24 mask, correct. Now, as we discussed, we are going to have repair.
You're on router 9.
Oh no. Oh no. I made a big mistake. I changed the IP address. Interface loopback zeros. Sorry. 9.9.9.9. It's okay. What a mistake I did.
You change F00 address to change.
Okay, that is 96 is okay. 39 I need to change.
Yeah. 39 should be 39.
Sorry. R7, R7, R7. Let us use the notepad so that we can use that for the next router.
Signal 7. It's 24.
This is on router 7. What next? I would like to go and change it on R8. R8 is going to be
also.
AUG RP 100.
I want to change it on R3 first, since that is also RIP.
Yeah, it is, but this template won't suit there. I'll quickly finish the other side. That's it. So this is going to be on route 8.
Did we already change those IP address?
Come again? We did. See?
Okay. No, okay.
So no more OSPF. Show IP OSPF interface brief. Nothing. Show IP GRP interfaces. You have. Okay. Now, as you said, we have to fix this VRF thing on R6 and R8. VRF addresses are not same. All right, on R3 side, first thing I want to do is go to the interface and change the IP address. F11.
Isn't that IP address in a VRF?
Yeah, but the interface is already in VRF. What happened? You remember? We already, not okay, you just try to recall. We already assigned that interface.
Yeah, I know.
So no need to.
Yeah, but I think we have to go in the VRF to change the address. On the interface, like inside the VRF.
Not like that. Not like that. Not like that. It is only membership. That command, you know, it will not take you to. Okay, I'll show you what you are trying to. But you will not see what you want to see. To show IPVRF. See, if I go inside, there is nothing called inside. IPVRF forwarding.
Oh,
This
okay.
won't take you to any mode. You are still in the same mode.
Oh, okay.
So that command is not every time needed. So
Okay.
what is IP address? 73.
Okay. 73 hours 36. 73, okay.
Okay. So now let us try pinging. Ping using VRF. This is the name 73.73.73.7. Good. If this is pinging, then we can go ahead with the VRF RIP. Router RIP version 2. Now, first go with the address family. Address family IPv4 VRF. Here you say version 2. Please understand. It should be under the VRF.
And I just found it. Yes.
So version 2. And lonely network is 73. Network. Only network is 73. Now, I should see a route if I type show IP route VRF. Do I? Yes, 192.168.70.
Yes.
Now this we need to put it inside the BGP. So I'm going to say show run section route BGP. And I'll go under this address family and redistribute this. So first I'll go under BGP. And then I'll go under this. Then there is no need for this.
Right.
Then I say redistribute RIP. That's it. Later, when route comes via VPN, I need to say router RIP. Address family is important. Redistribute BGP 20. And we have to say the metric. For EIGRP and RIP, if you don't say metric, if you forget, then the routes won't come. So I'm just going to say, like, it can be any number of hops. I'm going to say 2 hops for all those remote networks. Done. What is next is I would like to go to router 6 and configure under interface F1/1 IP address first. The IP address will be 68.68.68.68.6. Next. IP address is assigned. There we have EIGRP, so I have to say Now router OSPF2. Earlier I had OSPF2 for the VRF. I removed it. I should have removed even
Right.
on router 3. I'll do it later. Okay, let's do it before. Now going to router 6. Router EIGRP 100. Same like RIP. We need to say address family. IPv4 VRF. Oh, I don't know the VRF name. Let's go and find it out.
I think it's R1 to R8.
R7 to
It's R7.
address
R7
family
to R8. So.
IPv4 VRF. Belong to autonomous system 100. And networks are 68 only.
68.
Wonderful. We got the neighbor.
Why don't you just go ahead and
Yeah, we'll do it.
redistribute?
Okay, good. Let's do the redistribution part also. So further, you need to go again under the address family and say redistribute BGP20. Metrics are the K values need to be assigned. I'm going to say bandwidth is 100, 1000. Delay is 10. Just randomly in the exams and all, they will give you these values. Reliability, let me say 255. Load is not much. MTU is 1000. I'll say 1500. Now what next is I need to do the other way. Do show run section router BGP, and I need to go under this and redistribute EIGRP. Okay, so router BGP 20, address family IPv4 VRF this, redistribute EIGRP 100. That's it. Now we are expecting reachability between the site which has got RIP and site which has got EIGRP. Going to router 7 to verify the route. I do see 68. I'm very happy. The two seed metric that I gave us 2 is reflecting here, and it's coming from router 8. And now when I go to router 8, I should see the routes from router 7. I do see the external routes with administrative distance of 170 because it is redistributed from BGP, and it is coming from router 7. So if I will now ping this with 7, I'm able to ping. Trace. I'm able to see that the VPN label or the service label and the transport label. And the router 7 is not responding because I think I made a mistake. I didn't give the host number. Host number is mandatory. I just put 0. Here, when I trace route with 1, I'll get that last router. What?
Say show, when I say show IP route earlier on, you see 170 and you say it's because
Say again, what did you say?
BGP.
I didn't get it. Where on router 7?
You did a show IP route.
Oh, I can see dot 7 and not dot 1. I give dot 1.
No. When you look into the
Okay, that is
admin distance
administrative distance is 170 because
or
it
the
is
advertised
a
distance.
redistributed network. Correct. So I don't understand. What do you want to say on that?
So is it when you redistributed
Of
BGP, is
course,
it
yes,
170?
170. Go to routers. If you check in router 8, the routing table
Oh,
will
okay.
say 170. 170. Right. External route. For
Okay.
EIGRP,
BGP
BGP is
external.
external.
That's correct. You're right.
Oh, again, I don't know how long the recording was past. Anyway, let us now go and bring the internet in. We want internet. So we need a routing protocol between R9 and R3. I'm going to learn the routes. I'm going to learn the routes. I'm going to learn the routes in a special VRF on R3 and R6. So I'll go to R3 and I'll create another VRF called internet. So here we go. IP VRF internet. Route distinguisher, I would like to say 39:39. And I do not want to do route target right now. I do not want to do that right now. Okay, so I'll go to the interface that connects the internet. What is the interface name? Jesus. I think the interface name is 2/0. Yeah. So I'll go under interface F2/0. No shit. IP VRF forwarding internet. Okay. Now I give IP. See, what you said is correct for the first time. For the first time, when you give IP address, before you give the
Right.
IP address, you need to put that interface into the control plane of internet. Yeah, VRF.
Yeah.
Perfect. Now, once the interface is moved, now you can change the IP address anytime without mentioning the VRF again. Now, I'm going to say IP
Okay.
space address 39.3.0. Okay, so do show now do ping using VRF internet 39.39.39.9. It is pinging, which means our VRF is cool. It's working fine. VRF is good. Yep. Next, I want to do the similar thing on R6.
What's it, 6?
Interface F2/0. No shit.
And
Thank you.
do you already know your VRF?
IPVRF internet route distinguisher 6969 9696.
And R96.
Okay, now interface F2/0 IPVRF forwarding internet. Next is 96.96.96. 96.6. All right, next is I would like to test pinging. .96.96.9. We're able to ping. Okay, so this is fine. Next is we need a routing protocol to learn the route into the routing table. We need a routing protocol. So what protocol I will use? BGP. Yeah, BGP. Yeah. So
I think we said BGP.
we already have BGP 20 here. Address family IPv4 VRF Internet.
Right.
I need to say neighbor 96.
Neighbor.
9. Remote AS is 999. Okay, this is done. Now 6 is done.
Did we
Next
already
is
configure BGP and router 9?
let's
Oh,
go
yes,
and
there it
verify
is.
the routing table now. Show IP route VRF Internet. You see, we already advertised there on R9 and we are able to learn the route. Next, R3. Let's go to router 3 and say router BGP 20. Sorry, third 20. Address family IPv4 VRF Internet and neighbor 9.9. Remote AS is 999. What is next? Wait, okay, just come.
Should come up.
Let us check the routing table. Show IP route Internet VRF Internet. Okay. Now, you see, I'm going to export. I'm going to export this 9.9.9.9 and it needs to be imported on R1's VRF and R7's VRF. What should I do? Just say, as I said, I need to simply export. I'm going to say router IPVRF
No, into VRF.
Internet.
Internet.
I'm going to say route target. You can use any number of route targets and any number of imports and exports value. There is no restriction. So I'm going to say route target export value. This I'm doing for sorry, this I'm doing for router 1. So I'll say 13:13. 13. And route target export 73:73. Anything is okay. Anything is okay.
It's 37. It's 73 or 37? 73? Okay.
Yeah. Okay. So now this route targets I need to include to the VRFs which are already there. Do show IPVRF. So I go under IPVRF,
import
this one, and say route
+1,
target
+R1,
import
target
13:13.
13,
That's it.
13:13.
I don't import the other one. And then IPVRF
Right, you gotta go.
route target import 3737.
Just a second. 3737.
Now, as a result, I'm going to see that 999 route on R1 and R7. Let's go and check R1 and R7. R7, let me check first. Show IP route. Show IP. Oh, we need to redistribute. The reason is, here it is RIP. Here it is BGP. I think we have done already. We need to wait
No,
some
we haven't
time.
done it next week. We haven't done the other week.
These are all coming through BGP. We need to wait. Yeah, you see, it does. You got it. Likewise, on R1, I should see the route.
Yes.
Show IP route. Here also we see. But if you ping, the ping won't happen. Why? These two public networks are not exported to the internet. These two are not for the return traffic. See, if you are ping from router 7, what will be the source address? 73. Router 9 do not know where is 73. No, this is not inside.
What
this
I'm
is
saying
13, 13. This is 13 and 73.
Inside
this is public.
To be exposed to the internet.
So I need to now
Okay.
take the 73 and or I can write a default route towards R3. See, on the real world, see, the problem is on the real world.
No, let's export it.
If you say export,
let's export it.
Even 192.168 will get exported. Then you need to write a filter. You need to write a filter.
That's what I was talking. That's what I was
saying. We need to write a distribution list. Natting, if you do, then for this MPLS VPN, you don't need natting, isn't it? Then there will be issue. So only option is you need to use a distribution list and write hey, not needed. I'll go to R3 and simply save on simple redistribution. It will work. Or I can leak some route. I can leak some route by saying
right.
IP route for VRF internet. In order to go to 13.13.13 or internet, Just 13. Let's put 13 subnet. You need to in this VRF to go to this subnet. I need to say
use 13.
but fastness is in another VRF. Can I do like this? Yeah, I don't accept. Okay, it is showing something. Let's check. Show IP route VRF internet. Okay, I have no, that didn't come because that interface doesn't exist in this control plane. That's wrong. This is not the way it should be done. It should be should be done like this. We are going to leak the routes. Thirteen. 19:19. Now, this ping will happen because the route now by this time, yeah. So let's check that. Show IP route VRF.
It's in that VRF.
Internet. It has come now. Yeah, this one. Now, if I go to router 9, show IP route, I do see it. But I really do not want to see this. I want to see 13. I don't want to see this. I want to see 13. So ping will happen. 13 it won't ping. See if I ping this subnet.
But go ahead and try to ping. Try ping 13 and see.
It will very well ping. You know, R1 is pinging the ISP. But pinging a private address, it's not real in the real world. So we need only 13. So what we used in route, those methodologies and all okay, but in the real world, I should have not done this. Instead, I should have focused on 13 instead of focusing on 192. So what I'm going to do is to solve the problem. I'll also go to router 3 and do redistribution. Router BGP 20 address family IPv4 VRF internet redistribute connect redistribute VRF
Cost one.
redistribute. No, I'm under this VRF. Okay, redistribute VRF cast R1 connected only. This is more than enough. Oh, inter-reality distribution is not supported by BG.